Hello students, in this video we'll find the Schwarz-Christoffel transformation from the upper half space onto an L shape. So let's consider the following region. Okay, we're going to have a region like this in the upper half space. And this is going to be the point 1 plus I. We're going to go up at 1 plus I, and we go over like this. And so this is our region over here. That's the real line, right? That's going to be 0. And there's where we are. So this is our L-shaped region, right? And then we have like a fluid in this region, right? And I want to find the Schwarz-Christoffel mapping onto this region. Let's call this region L. Appropriately enough? Okay, good. What we're going to do is our standard trick. We're going to let 0 be one of the vertices of my Schwarz-Christoffel transformation. And then what I want to do is I want to pick a point over here, W2, which is some number R capital, and connect it to this point 1 minus I, which is going to be my W3, right? So region we're going to have is we're going to have this region, and then we're going to let R go to infinity and consider R approaching infinity, right? It looks like the old school, if you ever played the Adventure of Link, looks like the old Adventure of Link boot, if you're as old as I am, right? Okay, great. So there we have it, right? Let's look at the external angles now. The external angles as, of course, R goes to infinity, are going to be what? Well, the external angle over here at W1, so my K1 is just going to be equal to what? My K1 is just going to be equal to 1/2, right? 1/2, because the external angle is pi over 2. Okay, my K2 is going to be what in the limit? Well, in the limit, it looks like it's going to be 1, right? Just because I'm going to have a whole external angle of pi over there, right? And then what will happen at W3? At W3, you're going to have negative 1/2, right? Negative 1/2, because it's going to correspond to an external angle of negative pi over 2, right? So those are your external angles. Good. And so now what do we do? So now we can write down our Schwarz-Christoffel transformation. We're going to choose the finite points. Choose the finite points. X1 is -1, X2 is 0, and X3 is equal to 1, okay? So X1 is going to map to 0, X2 is going to map to R, and then X3 is going to map where? Over here, to that point. Excellent. Okay. All right, so now we have our information. So now we can set up our Schwarz-Christoffel transformation. So it's f prime of z. F prime of z is A, and then z minus 1, or plus 1 in this case, z plus 1 to a power, to the negative 1/2 power. And then z to what power? To the negative 1 power. And then z minus 1 to the power of positive 1/2, like that. Excellent, okay? And so now what we can do is we can write this in the following way. I'm going to write this in a nice way. What I'm going to do is I'm going to write this as A times what? A times, we're going to keep one factor of z minus 1 on the top. So I'm going to have the square root of z minus 1. And I'll put 1 in the bottom over here too. So I'll go negative, I'm going to put 2 on the bottom over here and get a what? And get a z minus 1 over z. Now I put an extra z minus 1 on top, so then you put 1 on the bottom, right? So I'm going to put it like this. It's going to be z squared minus 1 to the negative 1/2, right? And I might as well factor out a what? Plus 1/2 now. I might as well factor out an I. So this is going to be A times z minus 1 over I, z, and then z squared. Oops, now I pull out the 1 so I can make this look like something we like to see, right? What do we like to see? We like to see a 1 minus z squared to the 1/2, like that. Great, okay? And so now let's consider this expression over here. So what I can do is I can write this in the following way. I can write this as, so then this is going to be A. It's going to be A. And then break it into 2 parts. Z over I, z, 1 minus z squared squared. To 1/2 power. And then minus, of course, minus 1 over I z, and then 1 minus z squared to the negative 1/2 power, right? Good. So what's going to happen over here is we're in great shape because the z cancels out over here. And so this first guy is going to be very easy to integrate, right? So this is going to integrate to what? Just inverse sine, right? Inverse sine. Excellent. Now let's focus on the second term over here and figure out what that integrates to, right? So of course what I can do is I can put a plus sign here and put the I on top, right? So I have that expression over there. So I have that thing. So now let's consider an antiderivative of this. Of course, like I said before, this is going to integrate to what? This is going to integrate to sine inverse of z, right? I can throw that I into the a as a constant, right? So that's going to integrate to that. And let's consider the second integral over here, the integral of just d zeta over, or let's do z first, right? And we'll change to zeta. Okay, so this integral of dz over z, an I on top, and then 1 minus z squared to the 1/2 power. Let's let zeta be 1 over z, right? Then d zeta is equal to negative dz over z squared, right? Okay. And of course, that's the same thing as what? That's the same thing as zeta squared, right? So now we're in good shape. Okay, so what I can do is I can throw one of the z's over here, and so that's going to be zeta, with the zeta in the denominator, is going to be the same thing as negative dz over z, like that, okay? Excellent. So now, what does this integral give us? This integral is going to give us the integral of I, and I have a dz over z, but that's the same as negative d zeta. That's a d zeta over zeta. And then what? And then what we have? Then we have a 1 minus 1 over zeta squared to the 1/2 power. Okay, good. And I needed one more negative. So what I'm going to do is I'm going to put that I in the denominator, right? So put the I in the denominator, and you get the integral of d zeta over what? Pull that inside now. I can pull that inside. And if I do, I have a zeta squared minus 1, put the I back in there, and you're going to get a what? So you're going to get a 1 minus zeta squared to the 1/2 power. Beautiful. And that's going to integrate to what? The sine inverse of zeta, right? Which is the sine inverse of 1 over z. Good. So now we have our Schwarz-Christoffel mapping, right? So our Schwarz-Christoffel mapping, so I take this thing over here, and if we integrate, we get what f of z is. So f of z is a times sine inverse of z plus sine inverse of 1 over z plus another constant b is our mapping. And now I get to plug in the points and figure out a and b are, right? So what are the points a and b? Okay, so what I'll do is I'll plug in, for example, when I plug in x equals -1, what's going to happen over here? And I'm missing an I think. An I over here somewhere. Where's my I missing? Ah, there's a negative I over here, right? That I, I'm going to leave the I over there. So it shouldn't matter so much, but this is the basic structure of this, okay? Good. And so let's plug in, yeah, there should be an I over here. Where's the I go? Where did the I go? The I is not on this one, the I is on this one. So I'm going to keep that I in the integration over here. So I'm going to leave that as a negative I. So let's leave that I in the integration, okay? It will just help my calculation. All right. With a negative I. Okay, good. So now let me plug in -1. So if I plug in -1, I'm going to have what? -1 gets mapped to 0. So 0 has to be equal to f of -1. And f of -1 is a times what? Times negative I, negative pi over 2, negative pi over 2, plus b, like that. Because the sine inverse of -1 is pi over 2. And then when I plug in what? When I plug in 1, I get to 1 plus I. 1 plus I is f of 1. And that's going to be a times negative I times pi over 2, plus pi over 2, plus b, right? Good. And so let's solve these equations for a and b, right? So how do I solve these equations for a and b? Let me subtract the first equation. So if I do this minus this, I'm going to have 1 plus I is equal to what? 1 plus I. So if I subtract this from this, what's going to happen? The b goes away. I have an a. And then what happens over here? So these two terms, what will happen? So these two terms, so if I subtract this from this, we'll have a total factor of what? We'll have a total factor of, so this is really the same thing as I pi over 2 minus pi over 2. And this thing over here, so if I subtract these things, I'm going to have a negative I pi from those terms over there, and subtract those, I get a plus pi, right? So that tells me that A, so this is going to be A. So then A is going to be 1 plus I over pi, and then 1 minus I. Okay? We can simplify that a little bit, but let's just leave it as it is, right? So if I multiply by 1 plus I, what's going to happen? The top is going to turn into a what? A 2, just a 2i, okay, good, over pi times 2, so that's just I over pi. So A is I over pi. So let's plug that into this equation over here. So if A is I over pi, then what's going to happen? So then that says that 0, so 0 is going to be equal to I over pi times this thing over here is going to be a negative 1/2. Then we have I over pi, so that's a negative I pi over 2 times pi. So the pi is going to cancel out, so negative I over 2. Plus B is equal to 0, right? So that tells me what B is. So B is going to be 1 plus I over 2. Beautiful. And so now we can plug that in. So our final formula is just going to be what? It's going to be I over pi. It's going to be I over pi, then negative I sine inverse of z plus sine inverse of 1 over z plus 1 plus I over 2. And that gives us our Schwarz-Christoffel mapping for the mapping of the upper half space onto this boot-like region. And this is very nice because now we have like something like a sharp turn in a riverbed, right? So in other words, if there was a fluid here, the fluid would move down like this and go like that, right? And so you can find out what the streamlines of this fluid are going to look like. The streamlines of this fluid are going to go like this in this region over here. So we can now find out a formula for an inviscid, incompressible, irrotational flow in this L-shaped region, in this L-shaped canal region, which is very, very neat. So all that matters is the appropriate choice. I chose 1 plus I so that the calculation works out easily, right? So the whole point is that now it's basically a linear combination of sine inverse and sine of 1 over z as our Schwarz-Christoffel mapping. Thank you very much.